Today's video, we're going to show 4 examples on how to integrate using the technique called U-Substitution. And U-Substitution is to make integrals that are very complex and make them simpler so that we can integrate them. Here we have the complex integral of x cubed plus 1 quantity cubed times 3x squared dx. And when you do U-Substitution, as we stated in class, we want to let u equal whatever is inside of a function. So we notice right here that the x cubed plus 1, we're going to let that equal u. So we're going to have x cubed plus 1. Then we have to take the derivative of that. So the derivative of u would be 3x squared, and we'll write it in differential form, dx, because we took the derivative with respect to x. So now you notice this is what we let u equal, and our derivative is right here on the outside. This is our du. So our new integral, rewritten in terms of u's, is going to wind up being u cubed du. We went from really complex to really simple here, and we know that by just straight power rule, raise power by 1 divided by new power, we'll wind up with u to the 4th over 4 plus c. And then all we have to do is plug u back in. So our final answer is going to be 1/4 quantity of x cubed plus 1 to the 4th plus c. So that is our integration of this complex integral using U-Substitution. So let's look at another example. Here we have 4x cubed times the square root of 4x to the 4th plus 2. So again, recognizing what's inside, that's what we're going to let u equal. So we're going to let u equal the x to the 4th plus 2. And then our du, our derivative of that, is going to wind up being 4x cubed dx. So again, if I'm looking up here in terms of substituting, this is what right here, the x to the 4th plus 2, this is what I let u equal. And then I notice what's left over. I've got 4x cubed and the dx. That whole thing right there, those two things multiplied, or my 4x cubed dx, is my du. So my new integral, in terms of just u, winds up being the square root of u du. And as we've stated before in class, to integrate the square root of u, I need to change that to u to the 1/2 du. And again, raise power by 1 divided by new power. I'll wind up with u to the 3/2. Dividing by 3/2, same as multiplying by 2/3. And going plus c here. Then all I have to do is plug the u back in. And I have 2/3. Quantity of u was x to the 4th plus 2 to the 3/2, and then plus c. So there winds up being my answer for that integral there. Now, they don't all come out that nice. As you notice, the last two examples, the derivative of u was already in the problem. Well, now we have to make some adjustments here in the next two examples here. So if I go down here to this one, again, recognizing what's inside, I let u equal 5x plus 2, and I wind up taking the derivative of that, which is just going to be 5 dx. Now, if you notice here, my problem, here's my u. What's dx equal to? Well, I have to make my adjustment because I don't have a 5 here. So I have to divide this, treat this like an algebra 1 equation, divide both sides by 5. So I know that 1/5 du is equal to dx. So dx is equal to, right here, dx is equal to 1/5 du. And as we know from one of the properties of integration, that any constant we have, if we want to, can be pulled out front. So I'll have 1/5 the integral square root of u du. And as we did in our last example, I'm going to have to rewrite this as 1/5 the integral u to the 1/2 du. So I'll have 1/5 raised power by 1, so u to the 3/2 times 2/3, and then plus c. So cleaning this up, I'll actually have 2/15, and then plugging u back in with 5x plus 2 to the 3/2 plus c. So there is my integral with a little minor adjustment there of dividing by 5. Let's look at one more. Looks real complex, but again, what do we let u equal? We let u equal whatever's inside or in the denominator. In this case, we do have an inside that's already in the denominator, so this is going to be my u right here. I'm going to let u equal 2x cubed minus 4, and my derivative of that is going to be 6x squared dx. Now, if you notice here in the numerator, I've got x squared dx. This equation has 6x squared dx, so we're going to divide by 6. So my adjustment is 1/6 du equaling x squared dx. So my new integral now, it's going to have a 1/6 out front from the constant, and then it's going to be 1 over u to the 4th du. And then in terms to integrate this, I know I'm going to have to go with 1/6 to make it easy on myself here, u to the negative 4th du, so I can raise power by 1, divide by new power. And I'm going to wind up with u to the negative 3 over negative 3, which, cleaning this up, the negative exponent should go back down below. So I'll wind up with having here a negative, because of the negative here, I'm going to have a negative 1 over 18 for the 6 times 3. And then the u cubed that went to the bottom, and then I plug u back in here of 2x cubed minus 4 cubed, and then plus c. So there were 4 pretty good examples there of using U substitution. The first 2 with no adjustments, and the second 2 with adjustments.